Which element shows the largest jump between its first and second ionization energy? And we have B, which is boron, and then magnesium, sodium, and titanium. If we look at these answer choices, and recall, by the way, that ionization energy is the amount of energy required to take away a outer shell or valence electron, right? And if we think of, and the general trend, by the way, is that, of course, ionization energy generally increases going up the group and left to right in a period. So the general trend is this way. However, if we think about these answer choices, right, all of these actually want to generally lose electrons, right? Like, because boron has like 3 valence electrons, titanium is more on this side of the table, magnesium is an alkaline earth metal, sodium has a just 1 valence shell electron, right? So the first ionization energy is just going to be to take away that first electron, right? So what would actually happen is that when you take away that first electron, each of these is going to have a +1 charge, right? Boron +1, magnesium +1, sodium +1, titanium +1. But if you look at sodium specifically, sodium +1+ is actually what you usually see sodium as, right? And the reason is because this is very stable for sodium. If it loses that outer shell electron, it has the neon noble gas configuration, which is very stable. Everything kind of wants to have that filled outer octet, okay? And so if you try to take away another electron from sodium, making it sodium 2+, well, you're going to make it more like fluoride, and you're taking it out of that noble gas configuration, which is very energetically unfavorable, okay? And so generally, sodium has the highest second ionization energy, okay, for that reason, because it really doesn't want to leave that configuration. Now, magnesium, if you think about it, if you take away, if you have magnesium 1+, so that's after initial ionization, it actually wants to lose that second electron, right? Because as magnesium 1+, it's like sodium, and if it loses another electron, it becomes like neon, which is, again, very stable. So it actually probably has a lower ionization energy, okay? So sodium is generally going to have that highest secondary ionization energy, and this is why, right? Because you're going to be taking it out of that noble gas configuration.